Imagine you are in an interview. Things are going great, and suddenly the interviewer smirks and says, "Can you implement linked list? Can you implement linked list from scratch?" Boom! Just like that, now you are in a hot seat with hot laptop. Hey everyone, I'm Mr. Didi, the smart coder, and today I'll walk you through linked list, not in a simple textbook way, but like you are preparing for battle. So let us go. We will start from simple, but before that, what is linked list? By definition, it's a linear data structure where each element, we call it as a node, point to the next one. Yeah, I know. Definitions are boring. So we will look into diagram. You can consider this box is a node and it contains two things. Whatever value you want to store. Consider I want to store int variables. So I'll take 9. And the second one, that will be address of the next node, and that is how it point to the next element. Here I am considering address of next element as 100. It could be anything, not 100, it could be anything. For our understanding, I'll give address to this next element as 100, or I'll give 200, and I can give 100 for the first node. So it will be easy for our understanding. Address should not be in this particular range only, it can be anything. But for our example, I am taking more simple addresses. And for this third guy, consider address as a 300. Now this first element, this first node, it will contain some data. Consider I am storing int data. So I'll take 9 over here. Whereas in the reference variable of first node, I'll store address of second node. That is 200. You can see our address of second node is 200 over here. Same we will do for second node also. For data, I can take any integer. For address, I will take 300. Now here is the question. For first, I give 200. For second, I give address of third node. What could be address for third node itself? What can I store in the address variable of third node? And to be surprised, we don't have anything. There is no fourth element, so we can store null over here. There is no need of storing address. And this is example of linked list. We call this as a singly linked list. Why singly? There is only one single link. We can go in forward direction only. That's why it is singly linked list. If you have understand, we will write code for it, and that will make your understanding even more better. I'll open Visual Studio. Here I have created empty class linked list. I have not written any code. You can see over here also. We will write from scratch. And as I have told you, each element in linked list is a node itself. So first we will write class for node. And in node, see over here, we are having two variables. One, our data itself, and second one is second element itself. I know we are storing address, but in C#, address represent that entire element, whereas in C language we have pointer concept. So first variable, I'll take int, that is data, whereas second variable, I'll give name as next because it is storing next element, next node itself, and like this you can store next node. And Visual Studio is giving us this quickly line, that means we have to handle null scenario. And yes, in our example, node can be null also. At the last element, we have seen it could be null also. So that's why I am making it nullable. So this is our entire node. Yeah, nothing big, very simple. I will just write one primary constructor to get value for data and initialize that. And this is syntax for primary constructor that you can use from .NET 8 and later versions. Now as we have node, in our linked list, we have to store the list of node, right? But hold a second. I said list of node. Are we really gonna store entire list? No. What we generally do, we store address of first variable only. If you see in the diagram, this first node is connected to the second node with this address. So we don't have to store second element also explicitly somewhere else. We are already storing its address. Same for third. Whatever address of third we are storing into second. Over here you can see. So why to store that also explicitly? So for that, what we generally do, we create one variable named head, and that element point to the first node. and we generally refer that as a head. So that's why I'll take one variable. It will be private obviously because I don't want anyone to access it. And just to make it more efficient and optimized, we will take tail also. And if you might have guessed, this tail variable gonna store address for the last. That is, in our case, it is 300, the address of last node. And I will take one more variable, that is the count, so that I can get to know how many nodes I am having. Pretty simple, right? And this is our entire linked list. If you see what we are having node, and we are storing address of first node, address of last node, and total nodes, how many we are having. That's it. We are not storing anything else in between. We can have one node, we can have 1000 nodes. We don't care about that. We are only storing in our linked list, I am saying, because all the nodes gonna store address of its next node, so that we are storing. But in our linked list we are having only this 3 variable, and we don't need more variables, specifically singly linked list. Why I am pointing out this singly linked list word so many times? Because we have multiple types, and in further videos we will check out those also. This video is limited for singly linked list. Okay, so now we have linked list. How can we use this for our code? We need some logic to store our element into list. I may want to add element at first, at last. I may want to delete element. So I need some methods to do those CRUD operations. And for that, we will write our method. So let us start. First, we will write how to add element at first position. That is this first position. Even though I am having 3-4 nodes, but I may want to add my next node at first position only. That means this 100 location node gonna be the second one, and I may want to add any node before this over here. So for that we have to write one method. I will make that method as a public because we need to access this from outer side. This will return void obviously, and I'll take value. What value you want to add? Now think the scenarios. What scenario we need to handle over here? There could be two scenarios. First, we have no element with us. This is the first time someone is adding element into our list. So we have nothing. And in that scenario, this head gotta be null, right? Because no one has added any node yet. So obviously head will be null. And therefore we will check first, is our head null or not? If it is null, that means this is the first element we are adding, and we will directly add variable into head. And because this is the first element, tail also gonna be the same. Our head and tail both will point to this node only, because there is no other node created yet. So I will make tail to point to head. If head is not null, that means elements are already there, and we have to shift whatever first element is there to the second position, and we have to add our new element or node at the first position. And for that, what we can do, first we will store our head node into one temporary node. So I will create one temporary node and store address of head. Now whatever new node I am having, I will store that new node into head directly. Why I am doing that? I will explain you. In the next of head, I will store 10. Now see what is happening here. Consider these 3 nodes we are having currently, and that idiot user want to add his element over here before this guy, right? Now in our head we are having address 100, right? I will write over here head is 100. Now if you directly create new element and assign that to head, what will happen? Suppose this is the new element. Here currently nothing is there. I have created node only, and I store data 2. Address I am taking 50 over here. It can be anything. I am taking 50. Now if I directly store 50 into head, you might have guessed now we have lost connection to this entire list, because in next we are having null, and in head we are having only this one element. So obviously what I have to do, first I have to store this head somewhere else, and for that what I am doing, I am storing that 100 into 10, and now into head I am storing 50, and this above 50 I will remove. After storing this 50, whatever 100 we are having in 10, that 100 we are writing into this null place. over here, and because of that what will happen, link from this node to this node will get created, and now our entire linked list is also preserved. And not only that, we have successfully added this new node at the first position. And this is the thing that makes arrays feel jealous. Why? You might have guessed, if you want to store any element into array needs continuous memory. So if you are having memory for 4 places, because when you create array, you have to define memory at that time only. So you have given size 4 at that time, you can't store 5th element now. Whereas in linked list, we don't have limitations like that. You can store any number of element dynamically. Let's go back into code, and you might have noticed we are missing something over here, and that is our count. If you add new variable, we have to upgrade our count also, and that's why I'll make it count plus plus, and that's it. Add first is ready. But how you know that whatever element you are thinking that you have added are really there? You should have some logic to see all the elements that you have added, right? Okay, I got your point. Let us write one method to see all the elements that we are having in our list, and for that I'll write one method, maybe get out. We don't need any arguments for this, right? We have everything with us. And simple logic over here, we will take address of head into one temp. Why? Think guys, why we need temp variable over here? And if you got answer, okay, hold on. Scroll the screen a little bit and write your answer in the comment section right now. I would like to see your quick intelligence. And now come back. So I am taking address of head into one temp. I will write one loop. Why loop? So that from this head, this 50 is head, our head now. From this head, we will go on the second node, third node, and fourth node. And while going from first node to last node, we will print all the data. And to go from first node to last node, we need loop, right? And here I am taking while loop, because that is little bit easier for linked list. I will write this loop till my temp is not becoming null. When will it become null? Think, whenever you will reach at last location. See, at last, in the next, we are storing null. And in our code, what we are doing, we are updating temp to temp.next. So by doing this, what is happening? You are here in the temp, you are having 50 and you print the 2. Now what you did, you store address of temp.next into temp. What you are having in temp.next? That is 100. So now in your temp, you are having 100. And from this location, you came over here. Now you print 9. You again did the same thing. You store into temp.next. Temp is this entire node, whereas its next is 200. So now you are having address of node that is at 200 location. You jump from this guy to this guy. You print 12. And same gonna happen over here also. The only difference is when you will reach here and you execute the same line, now because of that in your temp you are having null. And that is the point when our loop gonna break. And as we are jumping from one node to another node like a monkey, we will print data also. And done. This is the entire code, guys. We will execute this and see is it really working or not. So I will create object of linked list, and we will call that add first method on this object. And pass some random data. Suppose I am passing 3 over here. I'll make some copies. Here I'll pass 7, maybe 9 and 1. After that we will call our get all method, so that at least we get to know that our code is working or not. So let me run the code and you be ready to see the magic. Wow, our code is run, and if you notice the output, whatever we have stored, it got printed in opposite order. So first we store 3, that came at last. Then we store 7, that came at second last. After 7 we store 9, that came on second position from start. And at last I stored 1, that came at first position. And what do you think? What is this indicate? This is indicating that our code is correct. Okay. Before going to the next part, quick question. There is one situation for you. You are in an interview call. As you already have imagined that you are in interview call, I have given you one situation. I have asked you to store 5 elements. But in your memory, the contiguous space available to store element is only for 4 elements. But the requirement is to store all 5 elements. How will you store? Which data structure will you use? If your brain bell is ringing, pause the video. Go a little down, scroll up, slightly scroll up, and write down the answer. Now come back. And the answer is linked list. Why? Linked list don't need contiguous memory. If you have memory for 4 location in contiguous format, that's fine. We are okay. We will store our 5th element at some different location. Now come back to our code. As we have implemented add first, obviously there should be add last also, because there might be some user that might want add last. So we will write one public method that will return void and add the element at last. As usual, we will take one data to store. Now what do you think, what will be the conditions for adding last? As we have 2 conditions for add first, that is our entire list could be empty, and the second condition, there could be some data, correct? So let us write code for those 2 conditions. So if head is null, what we can do, whatever new node we are having, we will store that directly into head. And as we did in add first, we will update our tail with the reference of header, and done. But for the second scenario where there could be existing list, here situation is little different. If you go back to the list and see over here, now we have to add our element after this guy, this last guy, highlighted one. And to add element after this, you need to know address of this, right? To know address of this last element, how can you come over here? You can come over here through the second last element only. We have only one link, but to come on the second, you first have to come over here, and to come over here, we have to go from the first element. So in short, if you want to add element at last, you have to traverse from first element like this to the last element. And after that, once you have address of last, you can add address of new node directly over here at the place of null. And just to avoid this traversal, we are maintaining this tail variable. Now you got why we have tail variable. In tail, we are already having address of the last node, so that we can directly jump over here with that address and change this null with the location of new node. Okay, so let us go back to the code. First, what we will do, we will directly add address of that new node onto the tail.next, and all set. This is your code for add last. Can you imagine it could be this simple? Really guys, the only thing we are left is that to update the count variable, and that is also completed. So if you want to test this, pretty simple. Come over here, I will comment add first part and I will write add last. Why there is error? Let me see. Okay, L should be capital over here. Small mistake anyone can do guys, ignore me. And now if I run this code, you will see same output in the same order that we have given. We got 3 and 1 only. We missed something. 3 and 1. Look at the code guys. What do you think? What we miss? We updated tail.next with the address of new node, right? Now come back to the diagram. Our tail was this one. We updated address over here at this location, but our tail was still pointing to this node only, this 300 node. Our new node, whatever it could be, by giving address of this new node over here, we created the link. So that part is set, but our tail was still pointing over here only. We haven't updated tail with the new address. If you go back to the code and see, let me close this terminal. If you go back and check over here, we updated tail.next, but our tail was still pointing to the older node only. It is not getting shift to the new last node. And for that, what we have to do, we have to change tail to the tail.next. And now if you run the code, boom, now compare this answer with our input. What we given 3791 and output is also the same. And these small errors like this can be happen in interview also, but you have to have sharp eyes to identify that. The more quicker you will identify error like this, the more you will have impression on the interviewer, those devil like interviewers. We will write one more method also, you can say as a complementary, that is adding the element at given index. So I'll write add at, I will take the data along with the index where that idiot user want to add his element. And this is the scenario where you need to check some additional edge cases. We'll see. There will be first scenario where there is no element. Our list is completely empty and that idiot user is asking us to store element at second position. Is that possible? No, right? So to handle that scenario, first we will check whatever count we are having. If that count is less than index, we will make count plus 1 and less than equal to. Why count plus 1? Because if you are having 3 node and that user want to add his element at 4th position, he can give index as a 4. And because your count is 3, you should not throw error to him. You should add element at 4th position. That's a valid scenario. And that is the reason we are checking count plus 1 should be less than equal to index. If it is getting greater than index, what we can do? We can throw one exception. Right. We will throw exception right on his face saying index out of exception. Perfect. If not, if my count is 0 and he also want to add his element at 0th position only. So if index is equal to 0, what we can do? We can call add first method. So here we will call add first and we will pass the data. So by doing this, we are adding element at 0th position. If this index is same as this guy, we should not have equal to over here, my mistake. So if the count plus 1 is same as index, that means that idiot want to add element at last and he don't know that we are having add last. So here are calling add at method. But we know that we are having, because we are following the smart coder channel, we will call add last method and we will pass the data over here. Now the only scenario that we are missing is that everything is valid. We are having total 5 element and user want to add element at second position. What we will do at that time? We will write one simple else condition and now we have to traverse through our index. And now we have to traverse from our head to the given location. That could be anything. So consider I want to add element at second location 0, 1, 2 over here. So this is my new element that I want to add at second position. So what do you think? What should done for that? Obviously we have to break this link, right? We have to make this link to point over here on this element and we have to create one new link that will go from this new node to the current existing second node, like this. Understand? So to make this new node, what we will do? We will store this 200 on the new node, whereas in the existing first node we will store address of our new node, that is 400, and boom, you added new element at the middle and you also got to know how to break the chain. Obviously we will see code also. So come back to the Visual Studio. First, remember what we do to traverse from head to the any position. First we create one temp and we store address of head, obviously. After that, with the help of loop, we traverse from head to that particular location. It can be anything. So from int I equal to 0, we will go till I less than index. See over here, to change address on the index minus 1 location, we have to stop on the index minus 1 location itself. If you go on the index location, you won't be able to break the chain. You need to stop on index minus 1 so that on that node you can change the next variable. That is why here we are having I less than index and obviously I plus plus. I'll write code for traversing, very simple code, and when this loop will get break, at that time you are on the location of index -1. Now you can't directly change temp.next, because if you first change the value of temp.next, that is this 400, if you directly put 400 over here, from this 400 in node, you won't be able to create link to the 200 element node, because now you don't have address of that 200 element node, because here by default you will have null. So how will you get address of this existing node? You have lost that. And that is why what we do first is we create new node. On the next of that new node, first we store whatever we are having into next of temp. We were having 200 on the next variable of temp node. Don't get confused over here. Imagine the diagram. We were having 200 over here initially, right? So now that 200 I have added into new node. That means over here I added 200. So link from this new node to this existing second node, you can say, or previous second node is created. Now only this link you have to create. And how you will create? Simple. In the next of temp, you will write new node, and that's it. Now the only thing remaining is that we have to upgrade our count. Now think why I am writing count plus plus in else condition inside this else part. Why I am not writing over here? I will not answer this question. You have to answer. Go down, scroll little bit and write down your answer right now. If you don't get the answer, if you write this code by yourself, I'm 100% sure you will get the answer. And still if you didn't get, so don't worry, in the next video I'll cover that. So add first, add last and add at. All three are completed. Just to make sure this is working, I will write one add at over here, and the index I will give, the data I will give 10, index I will give 2. So our output should be like 3, 7, 10, 9, 1. Right? Let me run the code. 3, 7, 9, 10, 1. Let me see. 0, 1, 2. We missed something, guys. Okay. What we are missing? We are starting from 0 and we are going index -1. Here is the fault. We have to write index -1. Yeah, I know I am doing little bit mistakes, but that's fine. It's not hard to identify this kind of mistake. If I did the mistake, then only you will focus. 3, 7, 10, 9, 1. Perfect. The answer what we were expecting. If I am doing this, and if you are able to catch that before I catch, that means you are focusing on it and you are actually understanding that one. And now the final thing. As we have written the code to add the element, we also have to write the code to remove the element. In short, or you can say to remove the node. Correct? So I'll make this minimize and let us start with remove first. We don't need any argument for this. And over here, first we will check is in our list are we having only single element, because if we are having only one element, that means our head is the only thing, we have to make it null. So I will have check on count. If the count is 1, I'll make head point to the null and all done. If not, whatever we are having into the next of head, I'll make that guy as a head. Are you getting the point? Let us go back into the diagram. Suppose I want to delete this element. The best thing that we can do is break this link. If we is able to break this link successfully, and if our head is pointing to this element, the highlighted element, that means this is our first element. And because there is no reference for our previous first element, you can say, garbage collection will make it get cleaner. That is not our duty. And that's it. That is remove first. No big check, nothing. Only thing we have to update the counters. Let us write remove last also. It is also very simple. We don't need any index over here. Here also we will have the same check that we were having over here. That if our count is only 1. And one more thing, I forgot to update over here. If our count is only 1, that means tail is also pointing to the head only. So we have to make tail null 2. Don't forget that part. Let us go back to the remove last. I have copied the code, pasted over here, and you can see If our count is 1, that means we have only one element. So we can directly make head and tail null and all set. But what if it is not? In this situation, as our tail help us to add last, it will not help us to remove last. Why? Because to delete last node, you have to make next of second last node as a null. That means this 300, you have to remove that and add null over there. And how will you go back? In tail, you are having address of the last node, and there is no way to go back in linked list, at least in singly linked list. That is why we have to traverse entire list. So what I will do, as my good old friend, I will take while loop. But before that, I need to have address of head into 110. Don't forget this part. And if you are having confusion with this line, write it down in comment section. We will take in next video. In while, now instead of having temp not equal to null, we will have temp not next not equal to null. That means this variable over here. We need to add one more next over here. Why? Because when will your temp dot next become null? It will be become null only when you will reach on the last element. This last element is your tail and its next is null. And we don't need address of last element. We need second last so that we can update that next. So for that we need to write temp dot next dot next. So this is the temp dot next means 300. Ultimately this node, and on top of that one more next, that means this null part. And when you will got over there, you will break the loop. And here simply temp equal to temp dot next. Good old logic. Once you break the loop, you can assume you are on the second last node. And the only thing that you have to do is, first you will make temp dot next as a null, and don't forget that last thing which we forget when we were doing add conditions, that we have to update tail also. That we forgot when we were doing add operations, and that is to update tail condition. So we have to update tail with the temp, not temp dot next. Temp dot next is pointing to the null, so not that. And here we will make our count minus minus. The only thing we are missing, that is remove add. Over here user will pass the location index from where he want to delete, and obviously the same conditions that we were having to add at, we need to handle those conditions in remove at also. So if the index is equal to 0, that means he want to do remove first. So we will simply call remove first method. Else if count is equal to index, means that idiot want to do remove last. So we will call remove last. One check that we have to handle, that is, what if he give index out of range? It can be anything. So we have to make sure index should be greater than 0 and less than count, less than or equal to count. If it is not, then we have to throw the exception. We will throw it directly on his face that argument no, it's index out of exception. And same this negative case scenario we have to handle in our add at also. We have not handled that. See, we are just checking one scenario. As you know, user can be idiot. We have to check index should be greater than 0. Okay, what I did, we can make it like this also. If index is less than 0, then we will throw the exception. Perfect. Where we were handling this check, and if all checks are okay, that means we have to actually remove that middle element. It can be anywhere in the middle, and to remove middle element we have to go, suppose I want to remove this element, this newly added element. That means I have to come on this element highlighted one, so that I can update the next that was pointing to the 400th location node. We will change that to this 200 node location. For that, first we will take temp. Never forget this temp part, because if you did operation directly on head, you will lose the head location. How? Try it out. After that, I will go with for loop. If int I equal to 0, then I should be less than index minus 1, because If this is the index, I have to stop over here only, over here, and I have to change the address. That's why index minus 1. And at last, I plus plus. And simple traversing logic. When you will come out the loop, that at that time, your temp is pointing to the index minus 1 node. And that means you can directly do this thing. Temp.next is equal to temp.next.next. Now pause this video and look at the code. What you understand from this line? Temp.next. This entire node is your temp. It's next means this 400. We are changing value of this 400 with the value of temp dot next means this node dot next means this node. And what is the address of that? This third node, it is 200. So you are adding 200 over here. That is what we are doing on this line. And after this, simple count minus 1 and all set. Let's go back and test it. We will write some more add logic 10. After this, first we will write dot remove first and remove last. Let me execute this guy. See the output. This 3, that was the first element that we have removed, so we got output from 7. And this 50, that was the last element, that also got removed, so we got the output till 10 only. The only thing that we have to check, that is remove add. If I give 2 over here and if I run the code before, okay, we got the output 3 7 and after that 1. 9 got deleted. If you see the index number of 9, it is 2 0 1 2, and boom, our code is working. And this is the entire code for single linked list. Nothing big, everything is very simple. The only thing that you have to focus, that is how to traverse over the linked list. That's it. And this is all our building blocks. Once you understand this part, solving the questions based on linked list will become very easy. So next time, if someone throws the linked list question at you, smile like the devil in movie climax and write this code like a boss. If you like the explanation in this code, or if you want to do some changes in the explanation, or if you want to go in some particular part in more detail, comment section is all yours. Go little down, write it in comment section, like this video, and obviously subscribe the channel. This is Mr. Diddy signing off. Stay curious, code smarter.